Okay, so in this lesson, we're going to take a look at what a function is and the average rate of change. Remember, in order for a function to exist, you can't repeat any of the x values. It's got to pass the vertical line test if you have a graph. And then the average rate of change is pretty much the same as the slope formula from Algebra 1, but we're going to write it a little bit differently. So the slope of the secant line is f of b minus f of a over b minus a, which is also equal to y2 minus y1 over x2 minus x1. So this is the formula you're more familiar with. So we'll deal with that at the end of the lesson. So we're going to go and start easy. And we're going to identify the domain and range of functions. Okay, so the first example problem says find the domain and range and identify it as a function or not. So your domain is going to be your x values. So my x values are going to be 2, -3, 4, and the 2 is going to repeat, so we don't write it twice. So 2, -3, and 4. Your range is going to be 6, 9, and 10. Okay, and we can see that the x values repeat with the 2, so it's not a function. And nothing more to it than that. The next problem, -2, -1, 3, 4. That's going to be your domain. -2, -1, 3, and 4. Your range, 5, 3, 7, 12. So there's no repetition of x values, so this is going to be a function. So you can say it is a function, yes, a function, doesn't matter. Okay, now we have a graph. So we got a pentagon here. So we want to identify the domain. So your domain, and we're going to talk about how to write it in interval notation if you haven't seen that before. So your domain is your x values. So my x values are going to go from -3 to 3, and they're solid points. So I'm going to write it in interval notation. Now this means the same thing as this right here. Okay? You put close brackets if it's equal to. Okay? You put parentheses if it's not equal to. Now your range goes with your y values. My y values go from, looks like -4 to 3. And they're closed points. So if I was going to write it in interval notation, it looks like that. Okay? And is it a function? Well, if I do the vertical line test, it's going to cross that vertical line more than once, so not a function. And there's nothing more to it than that. Next one, your domain. You got an open circle at -4, and this side's going to continue on forever and ever. So your domain is going to be -4 to infinity. Infinities are always open. They're always parentheses. Okay? So this is going to be x is greater than -4. If you want to write in the other notation. Now your range is your y value. So your lowest y value is a -1. It is a 1, and it looks like it's going to continue all the way up to infinity. So it's going to be equal to a -1, and it's going to continue to infinity. Okay, so this is going to be y is greater than or equal to -1. Is it a function? Well, none of the x values repeat, so yes, it's a function. Yep. Hopefully this section was pretty easy for you. And let's see. Okay, let's go to the next page. So we have a sideways parabola. Okay, so we got a sideways parabola here. So your domain is your x values. So your x values are going to go from 0 all the way out to infinity. And it's going to be equal to at 0 because there's a solid point. Your range is your y values. So it's going to go out to infinity this way and out to negative infinity. So your range is going to be negative infinity to positive infinity. If we want to write this, this is x is greater than or equal to 0. And this is going to be all real numbers. Okay? This does not pass the vertical line test because it crosses an x line more than once, so not a function. I need to add that to my list real quick of things to do. Write that down real quick, sideways parabolas. Okay, on to the next section. So we want to find the domain and zeros if they exist. Okay, so the first little type of function is a quadratic. So it's also called a polynomial function. So anytime a function is pretty much in a straight line, there's no division, no square roots or anything like that, the domain is always infinity, negative infinity to positive infinity, like that. Now, in order to find the zeros, you set it equal to 0. Okay, they have an x in common, so we're going to factor out an x. So we'll get x is equal to 0 and x is equal to a -5 for our zeros. Okay, now I set each little thing equal to 0 and solve for it. The next one is what we call a rational function. We're going to get more into rational functions as we go in asymptotes. But we're going to look at this, and it's difference of squares, so it factors. Okay, so your difference of squares is x plus 2 and x minus 2. Now, when we have a fraction, we can't have 0 on the bottom, so we have to set each little parentheses equal to 0 on the bottom. So our domain is always going to be negative infinity to positive infinity. X cannot equal to, in this case, a -2, and x cannot equal to 2. Okay? When we're looking at a fraction and we're trying to find the zeros, we just set the top equal to 0. So x is equal to 0 is your 0. Okay? Any questions, hopefully? Should be pretty easy. Now, when we have an even root, okay, so this is a square root. If it was a 4th root, 6th root, 8th root, those are considered even roots. You always have to have the inside underneath the radicand has to be greater than or equal to 0. Okay, so 4 minus 3x has to be greater than or equal to 0 for your domain. Now, we're going to solve for x, and we're going to subtract the 4 to the other side. And when we divide by a negative, we have to flip the gator mouth. Okay, so a little bit of review right there. And in this section, this day or whatever, we're going to do some inequalities review. So you'll have that information a little bit later. So remember, when you divide by a negative, you change the gator mouth. So x is less than or equal to 4/3. If I'm going to write that, your domain is negative infinity to 4/3, and it's going to be equal to, so we put a closed bracket. Okay, your zeros. Okay, your 0 is going to be 4/3 because I already set it equal to 0 and solved for it. Okay. Next one. So it's an odd root. You get the 5th root of something. So you can take an odd root of a negative number. So it doesn't matter that it's greater than or equal to 0. So the domain of a function that has an odd root index is going to be negative infinity to positive infinity. Your zeros, we're just going to set what's underneath the radicand, the you're going to set the radicand equal to 0. So x squared minus 4 is equal to 0. Okay, we can factor that or we can add it to the other side. I'm just going to add it to the other side. Square root, remember when we take a square root, we have to put plus or minus. So your zeros are x is equal to plus or minus 2. Okay, so this is going to be a combination of a rational function and a square root function. Okay, so with rational functions, your domain is always going to be negative infinity to positive infinity. Now, when you have this square root involved, a square root has to be greater than or equal to 0, but it can't be equal to 0 because it's on the bottom of a fraction. So what we're going to do is we set x minus 9 is greater than 0. And I'm just going to move the 9 over. So my domain is actually going to be x is greater than 9. Okay, if I'm going to write that, it's going to look like this. 9 to infinity. Okay. And so that's what that falls under. So anytime you have a radical and there's an even root on the bottom, you're going to approach it this way. Zeros, 4 will never equal to 0. So there will never be zeros for that function right there. Okay, so polynomials are straight line. They look like they're in a straight line. Their domain's always negative infinity to positive infinity. Rational functions are fractions. Okay, so we always set the bottom equal to 0, and that's what it can't equal. Even roots always have to be greater than or equal to 0. Odd roots doesn't matter. It's always negative infinity to positive infinity. And then when there's a combination of a rational function and even root, the root always has to be greater than 0, not greater than or equal to 0. Okay, on to the next page of examples. This lesson's kind of long. Sorry. Had a lot to do with functions. Okay, so this is a rational function, so we're going to factor this down. And it factors to x minus 4 and x minus 3. Okay, so the domain is going to be negative infinity to positive infinity. X cannot equal to 4, and x cannot equal to 3. Your zeros, 2x is equal to 0, so x is equal to 0. Okay, next one. We got a rational function, x squared plus 16. Now, it's super important that you remember this, that x squared plus 16 will never equal to 0. That's sum of squares. Sum of squares never factor. That's going to give you imaginary roots. Okay, and so your domain is going to be negative infinity to positive infinity. Now, to find your zeros of this, we're going to set the top equal to 0. So x plus 9 is equal to 0. So x is equal to negative 9. And we're done. Okay, the next section we're going to be dealing with plugging in function values. Okay, so we need to make sure that we're doing this without a calculator to the best of our ability. I don't think any of these example problems have huge numbers. Sorry, I had to take a coffee break. Okay, so we're going to plug in a 3. So we need to get good at not using the calculator. Okay, so we're going to plug in a 3. So 2 times 3 squared minus 3 times 3 plus 4. Now, if you didn't know what f of means, f of always means you take whatever this is and you plug in everywhere there's an x up here. So we have to do order of operations. Please excuse my dear Aunt Sally. So we have to do the exponents first. So 3 squared is 9. 9 times 2 is equal to 18. 18 minus 9 plus 4. 18 minus 9 is 9. 9 plus 4 is 13. F of 0. We're going to plug in a 0. Now, if you're on SAT and that sort of thing, you just look at the back number. The back one, the lone number without any x's, and that's your answer. That's always your y-intercept. F of negative 3. We're going to plug in a negative 3. Okay, negative 3 squared is 9. 9 times 2 is 18. 18 plus 9 plus 4, 27 to 31. Okay. F of negative x. So we're going to plug in negative x everywhere there's an x up here. So 2 times negative x squared minus 3 times a negative x plus 4. Okay, negative x squared, so anything squared is always positive, so we get 2x squared plus 3x plus 4. Okay? What this means is we're going to take a negative and we're going to change all the signs. Okay, so we're going to distribute a negative out to everything that is given above. So we're going to distribute that negative out. So we get negative 2x squared plus 3x minus 4. Okay, next thing, we're going to take an x plus 3 and we're going to plug it in everywhere there's an x. Now, anytime it's a squared, I'm going to want you to simplify it. Something quantity squared. Once you get above that, I really don't care if you simplify it or not. Okay, so we have to FOIL this out mentally. So we're going to square the first term, take the 2 in the middle and double it, square the last term, distribute that out, okay, and then we're going to distribute that some more, so we get 2x squared plus 12x plus 18 minus 3x minus 9 plus 4. We're going to combine our like terms, so we only have one x squared term. 12x minus 3x is 9x. 18 minus 9 is 9. 9 plus 4 is 13. And that's our answer. Okay, let's go to the next page. On the back. I'm just going to rewrite our function. It was 2x squared minus 3x plus 4. Okay, so you're going to see this in calculus when we do definition of a derivative. So all we're going to do is follow what it says to do. Okay? It says that we're going to take an x plus h and we're going to plug it in everywhere there's an x. Okay, so we've got this. Minus, I'm going to take the original function and I'm going to put it in closed brackets. So 2x squared minus 3x plus 4. Okay, so this part is f of x plus h minus f of x, and f of x was given up there, all over h. Don't forget you're all over h. So we're going to FOIL this out mentally. So we get 2 times x squared plus 2xh plus h squared minus 3x minus 3h plus 4. Distribute this negative out. Okay. And then I'm going to go ahead and distribute that 2 out. And don't forget this is all over h. Now a whole bunch of stuff is going to cancel. Okay, so the 2x squareds will end up canceling. The 3x's will cancel, and the 4's will cancel. So I have this term, this one, and that's all that's left on top. Now they all have an h in common, so I'm going to factor that h out. Plus 2h minus 3 all over h. And that'll cancel. So the whole goal is to be able to cancel an h top and bottom. And that's how you do it. So your final answer is 4x plus 2h minus 3. Okay, let's hopefully get through this next one a little bit faster. So it's same process. We have a function, and we're going to plug some stuff in. We're going to plug in a -1 into f of x. So a -1 cubed is a -1 plus 4 minus 8. So I get 3 minus 8 comes out to be a -5. Make sure that if it's to an odd power, it keeps the sign of whatever you're plugging in. If I'm plugging a 0, I'm just going to look at the last number. It's a -8. If I plug in a 2, f of 2, you get 2 cubed minus 4 times 2 minus 8. 2 cubes 8. 8 minus 8 minus 8 comes out to be a -8. F of -x, we're going to plug in -x in up there. Okay, -x cubed is a -x cubed. -4 times a -x is plus 4x, because a negative times a negative is positive, minus 8. Okay, a negative times f of x means we're going to distribute a negative sign out to each of those. Okay, so we get -x cubed plus 4x plus 8. And the last one, we're going to plug in an x minus 4 everywhere there's an x. So we get x minus 4 cubed minus 4 times x minus 4 and minus 8. And I really don't care if you simplify that one. Anything above a squared, don't bother simplifying. So you have to force yourself to do this without a calculator. This is going to be the toughest part of some of the stuff that you're going to be doing, is because you're so used to putting in 4 times 2 in the calculator, or -1 times 7 in the calculator. So we have to get out of that habit quickly. Okay? This will be non-calculator, so make sure you're doing this without a calculator. You can check yourself with the calculator, but you need to do it without a calculator. Okay, so let's talk about composition of functions. So composition of functions is when we're going to be adding, subtracting, multiplying, and dividing. That's usually what we talk about. So we're going to take two functions and do that. Now, this is actually called composition of functions, where we have f, and that's an open circle G. That stands for f composition G, and it's defined as f of g of x. Some people like to call it fog. Okay, G composition of f, or GOF, is g of f of x. So these might be things that you haven't seen before, but we're going to go through them. They're pretty easy to memorize. Okay, the first example, we're going to add these two functions together. So we're going to do 3x plus 4 plus 2x minus 3. Okay, we're going to combine our like terms. So we get 5x plus 1. Okay. Now, when we subtract them, subtraction's where a lot of people mess up because they don't distribute their negative sign out to the second term. So you have to make sure you distribute that negative sign out. So we get 3x plus 4 minus 2x plus 3. We're going to combine our like terms, so it's x plus 7. That's all there is to it. Next portion, we're going to multiply. So we're going to multiply 3x plus 4 times 2x minus 3. Okay, we're going to FOIL this out. First, outer, inner, last. So we get 6x squared. Outer is going to be minus 9x. Inner is 8x. And last is going to be 12, minus 12. We're going to combine our middle terms. So we get 6x squared minus x minus 12. Okay. If you want to use box method, use box method. It doesn't matter to me. But I'm going to say FOIL. You have to do what you have to do, however you learned it. Okay. Division. Division's the easy one. You just literally divide them. Like that. Now remember, when we divide functions and you have something on the bottom, it can't be equal to 0. So let's go ahead and set that equal to 0 so x cannot equal to 3/2. Okay? You're going to have something called a vertical asymptote there. F composition of g is f of g of x. Okay, so what it's saying is we're going to take the g of x function and we're going to plug it everywhere there's an x in the f function. So we're going to do 3 times, there's an x here, so I'm going to take that and plug it in there, 2x minus 3 plus 4. And distribute that out. So we get 6x, negative 9 plus 4 is a negative 5. Because that's 6x minus 9, right? Try not to skip too many steps. Okay, g composition of f is g of f of x. So we're going to take the f of x function and we're going to plug it in to g. So our g function is 2 times, we're going to take it and plug it in, 3x plus 4 and minus 3. So we get 6x plus 8 minus 3. We get 6x plus 5. Okay. Then f composition of f is like that, f of x. So what we're going to do is we're going to take the f of x function and we're going to plug it in everywhere there's an x. So we're going to do 3 times 3x plus 4 plus 4. Okay, so we get 9x plus 12 plus 4. So we get 9x plus 16. And that's just basic composition of functions. Okay, we'll do another little lesson over this subject. So we got a little more complicated terms. So we're going to add them together. X cubed minus 7x plus 5 minus 2x squared plus 2x minus 4. And we're going to combine our like terms. So we got x cubed minus 2x squared minus 7x plus 2x is going to be minus 5x. And then 5 minus 4 is 1 plus 1. You can cross stuff out. When we're going through and doing this stuff, people get confused whenever they're looking at my answer keys if I've crossed out stuff, I've noticed. So I'm trying to avoid that to the best of my ability. Okay, so f minus g. Now, like I said on the previous example problem, you have to make sure that you distribute this negative sign out. Okay, so we're going to distribute that negative sign out. Okay, we only have one cubed term, so it's x cubed plus x squared minus 9x plus 9. Next one, we're going to multiply. Okay, so this is going to be something you'll probably have not done. I want to make sure that we do a few of these. Okay, when it has 3 terms in it, not 2. Okay. The way I like to do it is I do each of these 3 terms to the first term, each of these 3 terms to the second, each of these 3 to the last term. So we're going to end up having 9 terms when we distribute this out. So x cubed times a negative x squared is a negative x to the 5th. Negative 7x times a negative x squared is a positive 7x cubed. 5 times negative 5x is a negative 5x squared. Okay, now I'm going to move on to the second term. X cubed times 2x is 2x to the fourth. Negative 7x times 2x is a negative 14x squared. And then 5 times 2x is 10x. And then I'm going to do all to the last term. So we get minus 4x cubed plus 28x, and then minus 20. Now we get to go through and combine all our like terms. I know it looks messy. It's just part of life. You have to deal with it. I'm going to cross that out so I know x to the fourth. We have one term. Okay, x cubed 7 minus 4 is 3. X squared negative 19 x squared plus 38x minus 20. Okay, so you just have to be careful when you're doing that. Next one, division. So we're going to do x cubed minus 7x plus 5 all over that negative x squared plus 2x minus 4. And the bottom isn't going to equal to 0, anything obvious. So you can just write out to the side. I'm not concerned about trying to find that. Most of the time they factor. Okay, f of g of x, f composition of g. Okay, I'm going to take the g of x function, I'm going to plug it into f everywhere there's an x. There's no simplifying on this, so don't try and simplify it. So negative x squared plus 2x minus 4 cubed minus 7 times negative x squared plus 2x minus 4. And then plus 5. So I took this function, I plugged in it everywhere there's an x up here. Okay, g of f of x. Goff. I'm going to take the f of x function, I'm going to plug it in everywhere that there is an x up there. Now make sure this negative is on the outside of the parentheses, what you're plugging in. Okay, so I'm taking the f function, I'm plugging it everywhere there's an x. And g of g, we're taking the g of x function and we're plugging that in everywhere there's an x. So negative times x squared, a negative x squared plus 2x minus 4 squared plus 2 times negative x squared plus 2x minus 4 and then minus 4. So I know this can get tricky, but it's super important that you understand how to add, subtract, multiply, divide, and plug in function values, not only for pre-cal and algebra 2, but for your SAT, because this is all over your SAT. Okay. I believe this is the last page of the notes. Yeah. And sorry, this is a long video, but you'll get over it. Okay, so when I'm adding functions, so I get some fractions up here. So 1 over x plus 2 plus x over x minus 1. So when we add and subtract functions, we have to make sure that we have a common denominator. So the first term is going to be missing an x minus 1. And the second term is going to be missing an x plus 2 on the bottom. Okay, so we need to distribute this stuff out and combine our like terms. So this is x minus 1 plus, we'll distribute that out, x squared plus 2x all over x minus 1 times x plus 2 Let's combine our like terms. X squared plus 3x minus 1 over a common denominator. Now, I don't know if you've noticed what I've been doing is, and I don't know if I said this earlier, we always write our polynomials in descending order of power. So it's not wrong if you don't do it that way. That's just generally how you write stuff. Okay? Now we're going to do subtraction. So we're going to do 1 over x plus 2 minus x over x minus 1. So it's the same notion what we just did. In order to add and subtract fractions, you have to have a common denominator. This one's missing an x plus 2. Okay, now here's the kicker on this one. You have to make sure you distribute the negative out. Okay, so negative x times x is a negative x squared. Negative x times 2 is a negative 2x. Okay, and then we're going to go through and combine our like terms, just like we did in the previous example. So we get negative x squared minus x minus 1. Multiplying fractions. So when we multiply fractions, we multiply everything across the top and everything across the bottom. So we can just leave it like this, x over x plus 2 and x minus 1. I'm okay with you leaving it like that in factored form. If you wanted to FOIL it out, be my guest. Okay? Dividing fractions. So let's talk about dividing fractions because we're going to spend a lot of time on division of fractions. And we've already covered this in the trig identities portion. So we're dividing 1 over x plus 2 divided by x over x minus 1. So this is called a complex fraction when we have a fraction inside of a fraction. So we always keep the top fraction and we multiply by the reciprocal of the bottom fraction. Like that. Okay? And so our final answer is going to look like this. That's it. So complex fractions, you keep the top, multiply by the reciprocal of the bottom fraction. Okay, average rate of change is this f of b minus f of a over b minus a that we saw at the beginning of the lesson. So we're going to start writing our slope looking like that. Okay, so this is your a and this is your b. So what I'm going to do is I'm going to start by plugging in my b. So f of 5 into this function. Okay, so 5 squared is 25. 6 times 5 is 30, so minus 30, plus 9. So it's a negative 5 plus 9. It's 4. And I'm going to plug in a negative 2. The negative 2 squared is 4. Negative 2 times negative 6 is 12 plus 9. So that's 16 plus 9 is 25. Now, when I go to use my formula to find the average rate of change or the slope of the secant line, it's going to be 4 minus 25 all over 5 minus a negative 2. Okay? So 4 minus 25 is a negative 21. And 5 minus a negative 2, that turns into a plus plus, so this is 7. So your answer comes out to be a negative 3. Okay? And next one. This is your A, and this is your B. So we're going to say f of 64 and f of 27. So cube root of 64 is 4. Cube root of 27 is going to be 3. Okay, so we're going to do 4 minus 3 over 64 minus 27. It's 1 And 64 minus 27, let's go out to the side and do it. 14, 7, 5, 37. So it comes out to be 1 over 37. Okay? So you see, I went out to the side and I did that. That happens. You might have to do that on a non-calculator portion of the test. You can't be afraid of it. Now, I do want to show you something in your calculator that y'all probably don't know how to use yet. And it especially comes in handy whenever we're plugging in function values. So let's take a look at this. We'll just use this example right here. Okay, so if I'm using my calculator on this, I'm going to put my function into y equals. So we'll say x squared minus 6x plus 9. And we all should be kind of familiar with the table, okay? But I'm going to show you how to use your table a little bit smarter. Okay, so you see how my table's blank? Okay, the way I get it like that is I go table set, and I put the independent variable on ask, and I hit enter. So previously, we had it on auto, and it's just generally on auto. So we used to have to scroll and do all this stuff. Now, what happens if you want to plug in something that's not on the table, like 9.3 or 10.9? Well, I'm going to leave my table set on ask, okay, the independent variable on ask, pretty much for all time. Okay, that way it's really easy for me to plug in my values. So I'm going to plug in a 5. Boom, I get 4. Plug in a -2. Boom, I get 25. Okay, so you can do that for any sort of function that you're plugging numbers into. Okay, so you need to be able to do it mentally as well as be smart about doing it in the calculator. So on the previous sections that we're plugging in numbers, like these example problems over here, go back and check yourself, and with the table, plug this into y equals, and just do 3, enter, 0, enter, and then -3, enter, and then you should get those numbers. Okay? So this has been composition of functions, a long lesson. So if you have any questions over this, feel free to reach out. Thanks, and have a good day.